Hello, today we are going to do two problems from ICSE 2019 mathematics examination. These are the problems, question number 2A and question number 2B. So let's read the question without wasting any time. So prove that x minus 2 is factor of x cubed plus x squared minus 4x minus 4 with FT or factor theorem. Hence factorize the polynomial completely. Okay then. So let's recall what factor theorem actually is. So factor theorem says that if we have a polynomial f of x, for polynomial f of x, in this case this is our f of x, if for polynomial f of x, if f of a is equal to 0, that means that f of x can be written as x minus a times some polynomial q of x, or x minus a is the factor of f of x, or x minus a divides f of x. Okay then. And why does that make sense? Because if f of a is 0, if you put a in this polynomial, this is also equal to 0 because 0 times anything is 0. Okay, so that means if I were to write this, if I were to prove that f of 2 is equal to 0 in this polynomial, that would mean that x minus 2 is a factor of q of x. Okay, a factor of f of x. Okay, so let's prove that. Let's find f of 2. That means wherever I see an x, I will be writing 2. Okay, so 2 cubed plus 2 squared minus 4 times 2 minus 4. This is 8 minus 8, those two cancel out. 4 minus 4, those two cancel out. That is 0. Since f of 2 is 0, by factor theorem, I know that f of x can be written as x minus 2 times some polynomial p of x, which means x minus 2 is a factor of x, or x cubed plus x squared minus 4x minus 4. Okay, now we have to factorize this equation completely. How can we? In fact, polynomial completely. Okay, bit of confusion. So this is x cubed plus x squared minus 4x minus 4. This is known as polynomial long division, and this is to find q of x. Okay, let's find q of x. X cubed plus x squared minus 4x minus 4. This goes by x squared, x cubed minus 2x squared, that is 3x squared, minus 4x plus 3x squared, minus 6x, that is 2x minus 4, and I'm running out of space here, but I know that it will be 0. So that's my q of x. This is my q of x. I'm going to plug it there. I'm going to rub all of my work in here. So now I know that my polynomial f of x can be written as x minus 2 times x squared plus 3x plus 2. And that means we can factorize it now, that x minus 2. What is the, we need two numbers whose product is 2 and the sum is 3. 1 and 2 seem to work. X plus 1 and x plus 2, those are our factors. So this is our factorized f of x. Yeah, f of x. Okay, let's move on to the next question. And the next question is, prove that cosecant of theta minus sine of theta times secant of theta minus cosine of theta times tangent of theta plus cotangent of theta is equal to 1. And this is a side note that this works for only theta that are not multiples of 90 degrees, because if you plug in 90 degrees or any multiple of that, one of these terms is going to be definitely undefined. Okay, so let's go ahead and prove this. And this I will be proving by LHS equals RHS. So I will be proving that left hand side is always equal to right hand side for the given theta. Okay, let's go ahead. What is cosecant of theta? That's 1 over sine of theta, reciprocal ratio. What is secant of theta? That's 1 over the cosine of theta minus the cosine of theta times the tangent of theta plus cotangent of theta. We write it here. Okay, this is LHS, the left hand side. Tangent of theta is sine of theta over the cosine of theta plus the cosine of theta over the sine of theta. Yeah. What does that equal? Well, we can actually take the LCM and write this expression as 1 minus the sine squared of theta over sine theta multiplied 1 minus the cosine of theta squared over cosine theta multiplied by, well, that's sine squared theta plus cosine of theta squared over cosine theta times the sine of theta. Okay, now what can we do? Well, we have to remember one fundamental equation which is also known as the Pythagorean theorem, which means that for a right angle triangle, if this is A, B and C, this is the right angle, this is theta, c squared is equal to a squared plus b squared, which means that 1 is equal to, if you divide both the sides by c squared, this is a over c squared, this is b over c squared. What is this? A over c is the same thing as the sine of theta. So this is the sine of theta squared, and this is the cosine of theta squared. Okay, using this equation, what is 1 minus sine squared of theta? That's the cosine squared of theta over the sine of theta multiplied by 1 minus the cosine of theta squared, that's just the sine of theta squared over cosine of theta multiplied by, this is 1. So that's 1 over cosine of theta times the sine of theta. Okay, now some magical cancellations, my favorite part. Okay, this is 1 theta cosine of theta, this is another cosine of theta, these are 2 cosine of theta squared, so that's out. These 2 cancel out, and this is 1, obviously for all theta, not the multiples of 90 degrees. Since LHS is equal to RHS, this means we have proven this. We have proven it. Yes. Thank you for watching.